Okay, this is our next video on bivariate scatter plots, and we're looking at line of best fit. So let's look at the next slide. Okay, when we display bivariate data that appears to have a linear relationship, we often wish to find the line of best fit that best models the relationship so we can see the trend and make predictions. We call this line the line of best fit. So we're trying to get a line that we can then extend and we can make predictions on. Okay, so let's have a look at this scatter graph that we've got here, scatter plot. So now there's several options for a line of best fit. So when we've got these, we've got the X, our independent, we've got our Y, and we've got these data points. Each dot is a data point. It's an X and a Y coordinate, and so they're in black. And then we've got the three possible lines that we're going to eliminate two, and one will be the best out of the three. So we can tell straight away that A, okay, so A is the green one. Well, that's going in the wrong direction. The data appears to have a positive linear relationship. So when we look at this data is sort of going up in a linear and a positive direction. So that one there is incorrect. So A cannot be even in the ball game. Then B, if we look at B, well, B is very much not in the middle. So B has a correct sign for its gradient, so it's positive, and it passes through 3 points. So 1, 2, 3. But when we look at it, there's a lot of points above that blue line. Okay, so it's not in the middle. There are way more points above the line than below it. So B is going to be out of it, so the blue one is out of it. And so that means that C, the red line, would be about our best line of best fit. So we should try to make sure the line of best fit passes through the center of all the points. So we're pretty much trying to get it in the middle. And out of those three, the red one is the best. This means that line C is the best fit for the data of the three lines. Okay, let's go through drawing the line of best fit by eye. So here's some methodologies and some pointers to help us to do that. So one method is to draw an oval around the points on the scatter plot, then cut the oval in half with a line. So if we did something like that, I'm going to try and do it by hand. If I did something like that, try and do this as best I can because I'm freehanding this. So I draw a bit of an oval, not very good at it. A bit of an oval like that around. Then cutting that oval in half would be from there to about there. And that's pretty much where the green line, if I got a ruler and drew it, then I'd have pretty well the green line. My oval wasn't that good, but might have a second try at that. So let's try again. So an oval around those lines, those dots, those data points. Whoop. Okay, again go from about the middle to about the middle. And again, if I did do that, then I would be pretty close to being able to draw that line of best fit. So that method there is not too bad at getting it. Now let's have a look at the other criteria. The line may pass exactly through all of the points, some of the points, or none of the points. All right, so there's a bit of a criteria there. It may also represents the general trend of the data, increasing or decreasing. So it obviously can't go into a negative on this one. It can't go negative. So if it was going that way, it would obviously be incorrect because we've got a negative relationship. The number of points above the line, so this is an important one. The number of points above the line should be the same as the number of points below the line. So generally speaking, we're trying to get, so how many have we got here? 1, 2, 3, 4 and 5 there probably. then we've got 1, 2, 3, 4, 5, and then we've got one that's on the line. So this is actually meeting that criteria very well. So try and have a look at getting the same number of points above and below. And you should generally ignore outliers. So if I had a point out here, I'm not really going to go, oh well, I'm going to try and do that, because the outlier is going to really affect it and really sway the data away from the general trend of that line, and that line should trend like that, generally looking like that. So if we take that into account, we're really putting it skewed from what the general trend of the data points are. So a couple of things there to look at. You could jot these down in your notes. Okay, let's use some of this previous knowledge to do this example. Determine which of the following graphs contains the line of best fit. Now, this one here, they all look sort of okay. They're all going in the right direction. But let's have a look. So this one here, I've got 1, 2, 3, 4, 5. And I've only got 1, so that's above the line, and I've only got 1, 2 below the line. So that's 2 and 5, so it's not really even. Here I've got 1, 2, 3, 4, 4 above, 4 below, 3 above, 1, 2, 3 above, and 1 on the line. Here I've got 1, 2, 3, 4 and 2, and I've got 2 on the line. Now this one here, let's have a look. 1, 2, 3, 4. 1, 2, 3, 4. So that's 4 and 4, so that fits that really well. It's on the right trend. And if we look at this, they're more in the middle. Okay, so this one was more to the a bit that way. A was more a bit downwards. This one was uneven. This one was a bit more upwards, and this one looks like the one. So I would say the best line on this is going to be D. Alright, so D should be the correct or the best option out of those 4 to have your line of best fit. So again, trend, how many data points above and below, and is it in the middle? Okay, example B, use the line of best fit to estimate the value of Y when X equals 4.5. Now 4.5 is here on our X value, so we've got to go up to our line and then across and find out what our Y value is, and you can sort of see what that's going to be. Now 4.5, just as a little discussion, is within the set of data points. So our data points are from 1, x equals 1 to x equals 8. And what that does is it's within the data point, so it's interpolation. So when we are using our line of best fit to predict inside the data points, then we're interpolating. And the thing about interpolating is that it is reliable. Okay, so interpolation is reliable. We could go, and if we were asked to estimate at 10, then we're outside the data points, okay, and that's called extrapolation. And we'll probably have a look at that a bit later as well. And that's not as reliable. Okay, so there's a couple of things to look at. So, but getting this line, let's have a look. So I get my ruler. I go up as best as I can on here. Go across, and looking at that, what is my value? It's so X equals 45. My prediction is Y equals 4.5. Okay, and this one here again is use the line of best fit. This is example C to estimate the value when Y equals 9 of Y when X equals 9. So now again, this is the same thing. Our interpolation is from X equal to 1 to X equal to 8. We're doing X equal to 9, which is outside of the data points. So our data points that we were given are all of these coordinates here, all of those data points. Okay, so this was extrapolation. Okay, so it's not as accurate, but because this is a fairly, it's a fairly strong positive relationship between the data points, then you could say that it's okay, but not as good as interpolation. All right, so let me just do this. I'm going to get from 9 and I'm going to work up. And it looks approximately, if I look at that point there, that's my Y value that I'm trying to say. So when X equals 9, Y equals 8.5 as a prediction. Okay, so it's only a prediction, and you could say that it's relatively okay, but not. You need to say that you've extrapolated, so it's not going to be as good as interpolating the data. Okay, hopefully that you got a couple of things out of that. You've got interpolating and extrapolating, and you've got positive, negatives, and a few things there. So go through and write these down as notes would be great.